Welcome to Statics Lectures by Soul Thinking, and in this class we will solve a problem on truss analysis using method of sections. Now before I move on, I suggest you please watch the video lectures on truss analysis one by one in sequence as in the playlist so that you understand better. The playlist link is in the description, or also you can click on the pop-up on your screen. Now coming to the today's problem, we have to find the member force in AB member. Okay, now this is the AB member and we have to find the member force in this truss, in this member. Right now I have already told you, if we have to find the member force in a particular member of a truss, in only one member or only few members, then we prefer method of sections because it saves time. And when we have to find the member forces in all the members, then we use method of joints, because in this problem we have to find member force in a particular member, that is AB member, so we will use method of sections. Okay, now there are some steps. First is to find the support reactions. So first we will draw the free body diagram of the whole truss and find the support reaction. Okay, so this is a hinge support, and in a hinge support we have two reactions. Okay, so let us call this as AY, and let us call this support reaction as AX. Why? Because I have assumed the horizontal directions as X, okay, and the vertical directions are Y. Okay, now this is AY means reaction at A, support reaction at A in the Y direction or the vertical direction, and AX means support reaction at A in the X direction or horizontal direction. Okay, similarly this is a roller support, and in a roller we have only one support reaction. Okay, so this is the one support reaction at C. Let me call this as CY, support reaction at C in the Y direction. Okay, now this is the free body diagram, and now we will apply the equations of equilibrium on this truss to find the support reaction. Okay, now the equations of equilibrium are summation of forces in the X direction is 0, summation of forces in the Y direction are 0, summation of moment at any point of the truss is 0. Okay, because this is a 2D structure, 2D truss, and in a 2D structure we have three equations of equilibrium. Okay, now I have already made a video lecture on equations of equilibrium. If you want to know more, please watch that video. Okay, but I will tell you that that video is not important because I will explain everything here. So let us begin. Let's apply this moment equation first. Summation of moment, let me choose the point to be point C equal to 0. Okay, I am assuming the clockwise moments are positive and the anti-clockwise moments are negative. Okay, now AY is going to exert a clockwise moment at C, so it is going to be AY multiplied by, we have to find the distance between force and the point where we are finding, okay, the normal distance between them. Now the normal distance between AY and C, because we are finding moment at C, so we have to find the normal distance between AY and C. Okay, so the normal distance is this 3 plus 1. Okay, 3 plus 1 is 4 meters. We have found the moment due to AY at C. Now let's find the moment at C due to AX. Because the line of action of AX is passing through C, so moment due to AX at C is going to be 0, so we will not write this term. Now moment due to 5 kilonewton. Now 5 kilonewton is going to exert a clockwise moment like this, right? So the moment due to 5 kilonewton at C is going to be positive, so I will write plus here, positive sign, 5 kilonewton multiplied by normal distance. What is the normal distance between 5 kilonewton and point C? Okay, the normal distance is dA, right, which is 4 meters. I hope you understand this. If you have any doubt, please comment. Okay, we found the moment due to 5 kilonewton. Now let's find moment due to 8 kilonewton. Now 8 is going to exert an anti-clockwise movement like this, right? So moment due to 8 kilonewton is going to be negative, so I will write a negative sign here. 8 kilonewton multiplied by normal distance. Normal distance between 8 kilonewton and C is what? 1 meter. Okay, now we found the moment due to 8 kilonewton. Okay, now the line of action of CY is passing through C, So the moment due to Cy at C is going to be 0, so we will not consider this term. Okay, as I can see, we found the moment due to all the forces and support reactions. Okay, so we have to equate it to 0, right? Now from here the only unknown is Ay, so when we rearrange this equation we can find the value of Ay. Okay, so let us solve this first. Now 5 multiplied by 4 is 20, and the units are going to be kilonewton meter, right? Kilonewton meter is going to be the unit. 5 4 is 20. Okay, so it is 20 kilonewton meter. 20 kilonewton meter. Similarly, this is 8 multiplied by 1 is 8, and this is kilonewton meter. Okay, so all of this is 8 kilonewton meter. Okay, now 20 minus 8 is how much? 20 minus 8 is 12. Okay, so all of it is going to be 12 kilonewton. 12 kilonewton meter is equal to 0. Okay, now let us throw this 12 kilonewton to the right side of equal sign, so it is going to be negative 12. Okay, so from here we will find the value of Ay. What? Ay is going to be negative 12 kilonewton meter divided by 4 meters, right? 4 meters. Meter and meter will cancel out, and this is 4 ones and 4 negative 3, right? So Ay is going to be negative 3 kilonewton. Okay, so we found the value of Ay here, so let me write it. Ay is negative 3 kilonewton. Okay, or rather negative means we have assumed this Ay reaction to be upwards, right? Negative means actually the reaction is opposite. Okay, it means the actual reaction at A is downwards, not upwards. Okay, so we will erase this negative because the use of negative is just the direction. We corrected the direction, and that's the only use of negative sign. Okay, so we found this Ay using this equation, right? Now let me erase all of this, then we will apply these two equations. Now let us apply this equation. Okay, summation of forces in the y direction is equal to 0. Okay, now I'm assuming the upward forces are positive. Okay, now this 3 kilonewton is downward, so it is going to be negative 3 kilonewton. This 8 kilonewton is also downward, so it is going to be negative 8 kilonewton. Now Cy is upward, so it is positive Cy. Do we have another force in y direction or the vertical direction? No, so all of it is equal to 0. Okay, now from here we will find the value of Cy to be what? 3 kilonewton plus 8 kilonewton. Okay, now 8 plus 3 is 11 kilonewton. Okay, so we found the value of Cy. Cy is 11 kilonewton, right? So we applied this equation, so let me erase this, then we will apply this equation. Now let us apply this equation. Summation of forces in the x direction, x means the horizontal direction, is equal to 0. Okay, I am assuming forces to the right they are positive and forces to the left are negative. Okay, now let's find the forces in the x direction. Now Ax is towards right, so it is positive Ax. Now 5 kilonewton, it is towards also towards right, so it is going to be plus 5 kilonewton. Do we have another force in x direction? No, right? So it is equal to 0. So from here the value of Ax is negative 5 kilonewton. Okay, so let me write this negative 5 kilonewton here, negative 5 kilonewton. Okay, now negative means initially we assumed the direction is towards right, but the negative means the actual direction is opposite. Opposite means it is towards right, so the actual is towards left. So let me correct the direction, so we will erase this negative sign. Okay, so in this way we found the support reaction. Okay, we completed the step 1. So let me erase all of this, then we will apply step 2. Now what is the step 2? Step 2 is this: cut the truss into two parts at member where member force is required. Now we have to find the force in member AB, right? We have to find the force in this member. This is AB member, right? So what we do, in the method of sections we draw a section. Okay, we cut the member where the force is needed to be find. Okay, we need to find the member force in AB, so we will cut the whole truss at AB. Okay, so like this. Now we have two parts, right? One part is all of this to the left of this section, and the right part is to the this, right, this side. Okay, remember there is a rule: when we cut the member, we should not cut, don't cut more than two members. Okay, more than, sorry, three members. Okay, you can cut up to three but not more than three. Now in this section, how many members are cut? One, two, and three members are cut, so we are okay. Okay, now what we will do, we will cut it at this section line. Okay, I will actually cut it, so let me use the eraser. Okay, so let me cut it here. Okay, now we have two parts. Okay, we have two parts in this. As you can see, this is the left part. Okay, and this is the right part. Okay, now in the step 3 we have to only analyze one part, either left or right. Okay, let me analyze the left part. Okay, so we have to, first we have to assume all the forces in the cut members are tensile. Okay, we have to assume all the member forces are tensile, all the forces in the cut members. Okay, the members which we cut, we will assume the forces in them to be tensile. Okay, then if we got a negative value after solving, that means our assumption was wrong and the force is actually in compressive force, right? Force is actually a compressive force. Okay, so we know how we denote a tensile force. We denote it with an arrow away from the joint, right? So let us say this is force in AB. Now this is DB member, right? This member is BD member. So this is force in, let me write here, force in BD. Now this is CD member, so this is force in CD. Okay, we have to consider only this part. Okay, the left part. Let me separate it. As you can see, we have to consider only left part. Okay, because I choose, we have to choose only one part. Okay, analyze only one part. Okay, either left side, left to the section, or right. Okay, all right, I choose this left. Okay, this is the left, we will analyze this. Okay, we have to find force in AB member, right? FAB, this we have to find the force in this member. Okay, now we have to analyze. What do you mean by analyze? Analyze means we have to apply again the equations of equilibrium. Okay, so we will apply all those equations, or maybe only few. Okay, because we have to find FAB. Okay, anyhow we can apply any of these three so that we find what? FAB. Okay, now first think which equation we will apply: summation moment, summation of Fy, or summation of f of x. Which one we will apply first? You have to think it, okay, in your mind, so that you find FAB. Okay, now you see, if we apply, as you can see, if I apply moment equation at D, okay, then we don't have to find the moment due to FCD and FBD, right? Because FCD and FBD are passing through D, so the moment due to these FCD and FBD is going to be 0. Okay, then will there will be two moments, moment due to FAB and moment due to 5, okay, at D, right? Because 5 and this 3 is also passing through D, so we will simplify that equation, we will find FAB. Okay, we don't need to apply these two equations. Okay, let me show you how. Now let me apply summation of moment at D equal to 0, assuming clockwise moments are positive and the anti-clockwise moments are negative. Okay, you can assume clockwise moments to be negative and anti-clockwise to be positive, it is your choice, but whatever you choose, stick to that assumption. Okay, now this FAB is going to exert moment like what? like this, it is anti-clockwise, so it is negative, right? So I will write negative sign here. Force in AB multiplied by normal distance between force and the point. Now what is the normal distance between this FAB and D? It is 4 meter. We found the moment due to this AB. Okay, and let me erase it. This is nothing. Now 3 kilonewton, as you can see, the line of action of 3 kilonewton basically is passing through D, right? So moment due to 3 kilonewton at D is going to be 0, so we will not consider this. Okay, now 5 kilonewton will exert moment what? It is arrow towards left, so it is going to exert moment like this. It is clockwise moment, right? So moment due to 5 kilonewton is positive. I will write positive sign here. 5 kilonewton multiplied by normal distance between force and the point, which is 4 meter, right? So we found the moment at D due to 5 kilonewton. Now moment at D due to this 5 kilonewton and this FCD and FBD, they are all going to be 0, because line of action of 5 kilonewton and line of action of these two, they are passing through D. Okay, D, so all of them is going to be 0. Okay, so we found moment due to all, right, everything. So I will equate it to 0. Okay, now this 4 meter and 4 meter, they will cancel out. So what we have here, we have negative FAB plus 5 kilonewton is 0, right? Now what we get when we simplify this, we get force in AB to be, when we throw it to the right, we'll get 5 kilonewton, right? We got the force in AB member to be 5 kilonewton, right? Now see, the 5 kilonewton is what? Is it negative value or positive? It is of course positive, right? Because we got a positive value and we initially assume the force is tensile. Okay, it, since we got a positive value, when we get positive, it means our assumption is right. Okay, if we get a negative, it means our assumption was wrong. Since we got a positive value, it means our assumption that the force in AB is tensile is correct. Okay, this AB member, okay, force in member AB is 5 kilonewton tensile. Okay, we denote the tensile force with this T letter. Capital T means tensile. Okay, so this is how we find the force in a particular member using method of section. Okay, now if you have any doubt, you can comment, and please give me a thumbs up if you really learned something, and see you in the next class. Thank you.